Hello guys, today I will be trying to briefly explaining what a machine learning is. So if there is a more demand or request on it, I'm planning to re-record more videos about more advanced techniques and code snippets from machine learning or deep learning applications. But let's just first start with the basics. So in that directory I have a two scripts for you, so let's start with the first one. In that script we have some numbers called x and y, like these are in machine learning called features. What does features mean? It's like the keys to a value or targets in that case. So let's say uh, there's a we will see in the upcoming example, but after we run the code you will have a better idea of what's going on here. So we are importing some libraries. This is NumPy, this is scikit-learn, a very famous applications. So they bring you some ready to use out of the box functions. We are going to use linear regression today. So we created a fake data we did for scikit-learn stuff. We defined our model we call fit. What does fit means? The fit tries to make a line or a graph, or it will be more clear when it's visual, tries to find the best line that describes the data more. So like in our example we will be investigate, like if we were work to x hours, how many of y coffees do we get? So code is like this. Let's just run it and talk it about it. So we ran the code. These are our data points. Like if you just work like 1 hour, you will just get two coffee, 2 hours, three coffee, blah blah. Like these are the number of coffees and these are the working hours. Our model try to find a line that is mostly close to what it should be. Like if I'm were to 2 hours on this line, I will get three, but I will get slightly more than three, but I'll get three in real life, so it's okay. Like we can clearly see, not quietly, but in an acceptable manner. Like it's better than random guessing right now. The model we created in milliseconds guessed how many coffee would we get from like the working hours. We can see from here, like it has guessed 6.4 coffees for 10 hours. Let's take a look at this. We'll actually get 6 or something, I guess. Like sorry, we would get 7, but we get 6.4, so it's quite acceptable. So why are we doing this? Imagine you have a you're an real established seller, or I don't know how are they called, and you have plenty of houses, apartments. The most famous apartment data set we are going to use, it's California house data set. It's a toy data set in machine learning. It's the one you always use when you start. It's like print hello world of the machine learning world. So let's take a look at the code. So here are many scikit-learn imports for getting the dataset, for dividing our dataset into train and test. I will explain what does that mean. For our models and for the metrics that we test our model, like how successful it is. So we get the housing data. In this data there are some metrics that is related to apartment. Think of it like its size, its number of rooms, its location. I don't know, like how many floors it has, or how many bedrooms it has. So you get an idea. If you were to have many number of these ideas, you could guess the price of a house only based on these specifications. So that's actually what linear regression is. As I wrote it here, in our example, we have 8 descriptors. Like it's just solving this equation, then getting a y. So let's load our data. I'm printing this. We are gonna show the shape of the data, like how many descriptors are there and what are the names of them. We need to divide our data set. Why are we doing this? Because in machine learning, if we train like data is valuable and hard to find. If we use all our data for training first, we don't have any data to test our model left because the model has seen all the points or values. So we, how can I say, we extract. It's like, okay, I will train my model on 80% of the data. Then I will use that trained model on this left 20% data to measure how successful my model, like it's like computing how successful my model is in real life. It's not completely like this, but you can think of it like this here. So in these two magical lines, models are trained and fit to that point, as we've seen before on copy example. And we made the model predict and some print something, and so I don't show the rest. So let's run the code again. So, oh, there's quite a mess here. Let's clear the screen. Okay. I just want to have a clear view. Let's run this again. So we have a 20,000 entry of house prices with 8 descriptors. These are this median size, house age, yeah, room count, bedroom count, population of the place, like the latitude and longitude are x and y coordinations on the map. So our model has guessed prices like this. So for like, this is not like the best model, but it's better than random guessing. So the R2 score 60. That means it's quite better than random guessing, but it's not enough. So what does R score mean in tech? It is, as mentioned here, it's a statistical measure to represent the proportion of the variance for a dependent variable, like how much percent of it explained by that variable. If you are interested in more, you can go to Investopedia and read more about R squared. So let's get back to our code done today. It's actually fitting to that equation to the with this valuable value. If we take a look at this graph, like our model mostly and correctly predicted, like it gives you the general baseline idea of how does the price changes according to the features. So that's for this today. Let me know in the comments if you are interested in more and like dive more deep into the topic. So take care.